The test to determine if a function is even or odd is built into this definition. A function is an even function if f of negative x equals f of x. We saw this actually in a previous section. If those two functions, f of negative x and f of x, are equal, then it is symmetric with respect to the y-axis. On a graph, we can see if the point negative xy is also on a graph when the point xy is. A function is odd if f of negative x equals negative f of x for all x in that domain. It's symmetric about the origin in that case. To check, if we take the point xy that's on our graph, we would also have the point negative x, negative y on the graph. And then some graphs are neither even nor odd. Now let's look at a few graphs. We want to determine if these are even, odd, or neither by looking at the graph. Okay. Well, again, we want to look for things where they are symmetric about the y-axis and where they're symmetric about the origin. Okay. One of the most common examples of this is an even function, something like this. This is y equals x squared. And something that is odd is something like this. It's actually a trigonometric function. Okay, where if you look at the respect to the origin, we've got this and this. Those are reflected in some way. It's actually more of a rotation about the origin. If you took this segment right here and you rotated it over, then you would have that. Those are a couple of just examples of functions of graphs that are even or odd. So A appears to be even because we are symmetric about the y-axis. You have a mirror image thing going on here. All right, C definitely is not symmetric about that axis, but it does look like it might be symmetric about the origin. Because if we take a point, say the point 1, 4, well, then based on our definition, we should also have the point negative 1, negative 4, which is in fact on that. Similarly with 4, 1. So this appears to be odd, and this one, B, is actually neither. Doesn't appear to have either kind of symmetry.